Number 2, a vessel in the form of a hollow hemisphere mounted by a hollow cylinder. Okay, so there's a hollow hemisphere here, and then on top of it there's a hollow cylinder mounted, right? And they've given us the diameter of the hemisphere equals 14 centimeter. From here till here is 14 centimeter. So even the diameter of the cylinder will be the same, which means even the radius will be equal again. Okay, radius of the hemisphere should be equal to radius of the cylinder, and the total height of the vessel from here till here is how much? 13. Just going to find the inner surface area of the vessel. So how do you find? It will be inner curved surface area of the hemisphere plus inner curved surface area of the cylinder. All right, so just remember that the inner and the outer curved surface area will almost be the same in almost all the cases. Okay, this way you can see I've just written the curved surface area and curved surface area. Okay, but it's the same thing with the inner curved surface area. Okay, and so that is what we asked to find, right? So you can see here diameter they're equal, even radius will be equal. They've given us the height of the vessel. Now let us find the height of the cylinder from here till here. They have not given, right? So first thing you have to understand is the radius of the hemisphere is equal to height of the hemisphere. All right, once again, the radius of the hemisphere equals height of the hemisphere. All right, which means radius is how much? We got here 7. We got 7, right? So from here till here is 7. So how do you find the height of the cylinder? Total height minus radius or height of the hemisphere. Then I'll get the height of the cylinder. Okay, why? Because when you look at the formula for curved surface area of the cylinder, it is twice pi r h. I have to know the height of the cylinder. Okay, so you can see here height of the cylinder equals height of the vessel minus radius or height of the hemisphere. So 13 minus 7, I'm going to get 6. Okay, now we know all the values, we just have to put it directly, right? So inner curved surface area of the vessel equals curved surface area of the hemisphere plus curved surface area of the cylinder. Okay, curved surface area of the hemisphere, the formula is twice pi r square. Curved surface area of the cylinder is twice pi r h, right? Now when you look here, twice pi r is common, right? So you can see I've taken it out. Okay, so when you look at the first r square, right, I've taken out 1 r, that means still 1 r is remaining. In the second, I've taken out twice pi r. What is remaining? The height is remaining. So you can see plus h is there. Right, nothing to do, we just have to multiply now. Pi is divided by 7. I've written radius, we already know 7, right? Again, radius is 7. Height of the cylinder is how much? 6. Okay, once we're done with that, 7 to 7, 7 to 7, then 7 plus 6, I'll get 13. Multiply these three, I'm going to get the total inner curved surface area of the vessel to be equal to 572 centimeter square.